So in the last video, I forgot to talk about coterminal angles. So if you're sitting in a circle and that circle is centered on the XY axis, we talked a little bit about standard position. Standard position means the initial part of the angle is on the positive x-axis, and the terminal side of the angle is wherever it ends up landing. So coterminal angles are two angles that are in standard position whose initial side are on top of each other. So for example, I could have a 45-degree angle that ends right here. So it's 45 degrees this way. And I could have an angle that's 45 plus 360, which is 405. Because a 405-degree angle would go all the way around and come back, and it will end on the same place. So that's a coterminal angle. We also can go the opposite direction. So if I'm sitting on the XY plane, and I spin negative 315 degrees. So that would mean start here and turn this way 315 degrees. You notice that I'd end up at the same place as the 45-degree angle. So a 405-degree angle, a 45-degree angle, and a 315-degree angle are all coterminal angles because their terminal side is all in the same location. Okay, so again, we learned coterminals, but also we learned that you can go either way. If you spin in the counterclockwise direction, that is a positive rotation. If you spin in the clockwise rotation direction, that would be a negative rotation. Okay, so now we have a good idea about angles. We can talk about some other things like arc length. So if I have, oops, I didn't mean to do that stuff in the middle. If I have a central angle, that central angle intercepts a certain arc. So, and we're talking about this arc right here, from here to there. So we could talk about the arc length. That would be the distance along that edge of the circle. So what we know is that if you go all the way around the circle, that would be the circumference. That is 2 pi times radius. At least I'm assuming that you've heard that before. So that would be a complete trip. If I go all the way around like this, that would be 2 pi r. Now, if I don't want to go all the way around, if I just want to go from here to here, I'm only going a part of the circle. So that means I need to figure out what fraction of this that is. So we usually signify arc length with S. And so what you're going to do is you're going to take some fraction of this. So we know that if you go all the way around the circle, that's 360 degrees. So if we only go theta around the circle, this would represent the fraction of the circle I'm talking about. So that would be the fraction of the total circumference. So we just multiply that by 2 pi r. Now, if you're measuring this in radians, it would look like this: theta over 2 pi times 2 pi r. And notice that the 2 pi's cancel out. So if you're measuring in radians, arc length is actually just theta times radius. Isn't that interesting? And it reminds us of what we talked about with radians. And radian is a measure. 1 radian means that the arc is a radius long. So you can see if I put a 1 in there for radians, you would just get r. Okay? So that's arc length. And you'll have problems that deal with that. For example, if I have a bike, this cute little bicycle, you're riding a bike, and you know that the wheels have a 26-inch diameter. If you roll, if your wheels, if your tire turns, I don't know, say 30 degrees. So not a complete rotation, just turns 30 degrees. We might want to know how far that would move the bike. Well, if you think about it, if the tire is turning 30 degrees, then the bike is going to move forward, obviously, and it'll move forward the same distance as the arc length that's intercepted by that 30-degree angle. So this is really an arc length question. So the nice thing is if we want, we have this nice little formula here, so we could say S is just going to be equal to theta times R, but of course that's in radian. So since we have this in degrees, we would say S is equal to 30 over 360 times 2 pi r. And of course the zeros cancel out. S is equal to, let's see, 3 are going there 12 times, so that would be, well, let's see, that will cancel that, leaving 18. 3 will cancel that, leaving 6. And the radius, of course, is, the diameter is 26, so that means the radius is 13. So we end up with pi over 6 times 13. Or in other words, 13 pi over 6. And we could put in 3.14 for pi, and that would give us a distance in inches that the bike moved. Now, if we go back up here, we could have turned this into radians. Remember we talked about the conversion ratio in the last video. So 30, if we multiply that by pi over 180, that'd be degrees, that'd be radians. The degrees cancel out. That would be end up being pi over, zeros cancel out, over 6, because 3 and 18. 3 and 18 reduced to 1 and 6. So then we would go S is equal to pi over 6 times the radius, which of course we already said is 13. And notice we get the same answer, 13 pi over 6. So you could convert it to the degrees into radians, or you could just plug it into this formula. Okay, and that's an arc length question. You also could be asked a area of a sector, and it works very similar to the arc length question. That if I have a circle, a sector means that means we're talking about this space in here. So if I want to calculate the area of the sector, I would need to know the radius, because it'll be similar to the way we said before. If you had the whole circle, the area we know would be pi r squared. But since we're only talking about part of the circle, we have to figure out what part of the circle, what fraction of the circle. And if this is, say, a 40 degrees angle, then the area would be 40 degrees divided by 360 times pi r squared. And A is equal to, so the zeros cancel out. 4 over 36 is 1 over 9 times pi, and since the radius is 5, that would be times 25. So we end up with area is equal to 25 pi over 9. And that, of course, if this is in inches, let's say, that would be inches squared, because we're talking about area. Okay, so that's a little rundown on finding area of a sector, arc length, and also just the idea of coterminal angles and what a negative angle means versus a positive angle. All right, you should be at this point ready to tackle homework 1 if you've watched both videos.